Hello there. Once more, we're going to continue on. Definitely, this I believe is going to be the last presentation for aircraft fuel systems. So let's have at it and get it over with. This subject, we're going to be talking in general about inspecting, checking, servicing, repairing aircraft fuel systems. Mostly some catch all topics. Um, When the mixture control on a normally operated engine is moved to the idle cutoff position, the RPM should slightly increase before dropping off to zero. So if you watch the RPM gauge, and if you're maintaining, let's say in this case you're maintaining 23, you might see it go up to 24 and then die off. Um, a rise to and those are times 100, so a rise of 10 to 35 rpm should be seen. um, so that'd be like 2300 to 2400. I don't think you're going to see that big of a difference from 2310 to 2300 on this type of tachometer. Um, but the reason you do get it a little bit because you adjust it so you're not operating at the most rich mixture, so you're going to actually pass through that stage when you're taking it to idle shutoff or idle cutoff. Um, and you keep it slightly richer than optimum for cooling purposes. So I guess um, you're going to take it to the better part, which is a little leaner. So there's probably a question that has to do with that. No, here it is. When moving the mixture control on a normally operating engine to the idle cutoff position, engine RPM should, what would you expect the engine RPM to do? Oh, we just talked about it. It's going to increase slightly, 10 to 35 RPMs before it starts to die. So I like that. That's A. B, slightly decrease and then drop rapidly. C, remain the same until the cutoff is affected, then drop rapidly. So we like A the best. The reason is because you run a little richer than necessary, so that'll keep the components cooler and there'll be more efficiency. Um, the ratio that produces the best burning, you're going to pass through that on your way to the idle cutoff position. I'm not sure if they call that the stoichiometric mixture. Uh, doesn't look like we're going to cover that concept in this class, so I haven't seen it pop up so far. Checking fuel nozzles, and I attempted to show you a fuel nozzle here. You can see the fins on the presumably on the piston head. Um, Injector nozzles do not require much service, but every 300 hours of operation, they should be removed from the engine and checked. A clogged nozzle can be located by the presence of fuel dye stain on the cylinder head around the nozzle. And okay, I see a little fuel dye stain. Um, and the question is, the presence of fuel stains around a fuel nozzle would indicate, what would that indicate? Um, is it too much fuel pressure? B, excessive airflow across the venturi? Or C, a clogged fuel nozzle? Oh, a clogged fuel nozzle. The fuel has nowhere to go, so it's kind of pushing its way up anywhere it can around the fuel nozzle. It's indicating it's clogged. If it was clogged, the fuel would take the path of least resistance. So C. You'll see the fuel stains on the cylinder head around the clogged nozzle. Fuel leaks can be classified. Basically, you dry the area and normally put down a compound. I forget what kind of talc it is. I believe it's a reddish talc. And then you time it for 30 minutes and then measure the wetted area. The basic classifications, as you can see, are a stain, which goes up to a 3/4 max. I've also seen that called a light seep. A regular seep is 3/4 to 1.5 inch. A heavy seep is 1/2 inch to 4 inches. And if you go much past that, particularly when you see the fuel flowing, that is a running leak. As a general rule, which statement is true regarding fuel leaks? A. Stained seeps and heavy seeps are not flight hazards. This kind of ties into a little bit of your reading. All fuel leaks, regardless of location or severity, are considered a hazard to flight. Or stained seeps and heavy seeps, in addition to running leaks, are considered flight hazards when located in unvented areas of the aircraft. So which statement is true? Well, first of all, I would say A is not true, because a heavy seep, that seems like that could be a flight hazard. And even a stain or a seep could be. That's a separate analysis. All fuel leaks, regardless of location or severity, are considered a hazard to flight. Now, that might be a little too far in the opposite direction. So we can't go from these are not flight hazards to these are all flight hazards, or let's see what C is. Hopefully it's a compromise. Stained seeps and heavy seeps, in addition to running leaks, are considered flight hazards when located in unvented areas of the aircraft. I like that one. That is about the only true statement. The other two are way too extreme. It's interesting that they say that they're not a flight hazard, even if it's a running leak. That seems to be a little extreme, unless it's located in unvented areas. So if it's a vented area and you have a running leak, that's not a flight hazard. And that's debatable. But the correct answer of these three is clearly C. How is a fuel leak indicated on a reciprocating engine-powered aircraft? How is a fuel leak indicated? Perhaps with the fuel pressure gauges and operating the valves. Ooh, I'm wrong on that. The dye that is in the gasoline stains the area around the leak. All right. We did look at the clogged fuel nozzles creating a stain, but apparently, certainly if you can, I don't know about that. I don't know if they've continued that question. That's not the best answer, because it could be an internal leak. So how are you going to observe a dye? So I'm not exactly sure about that. But if you give a number of reasons, including my answer about observing the pressure gauge while while working the valves, or looking for visible signs of leaks. Certainly on the tarmac itself, you're going to look for leaks, and when you're inspecting the various parts of the fuel system, they're going to shut you off by then. So you just start talking and you've got it right. Here's a 402B. It's out. It's in the hangar there at Building 90. So I thought I would include this. So check the schematic of the fuel system. That's the most useful document you can use when troubleshooting the system, or at least you see where everything is. So if you see you have a leak in this area, you're going to probably look around, maybe at that selector valve or this drain valve, or perhaps the line going to the fuel tank. Doesn't, but it does. Just as I said that, the text does say that the schematic does show how they function, but it's not necessarily at that part of the aircraft, although it's going to be near that part. So it's good to understand the system overall to detect any type of leaks or to do anything with the system. Understand it, and the best way to do that is the schematic, and that gives you an opportunity to see all these little tanks here. There's auxiliary tanks which are optional, and you won't actually see those in the aircraft. You will see the tip tanks, and you've actually got the main tanks, which are bladder types. We open them up so that you can see what they look like. Which of the following would be the most useful to locate and troubleshoot an internal fuel leak in an aircraft fuel system? Now that's internal, so it may or may not manifest itself externally. But what's most useful? A, aircraft structural repair manual. Well, if you were repairing the skin of the aircraft, that's one thing, but not a fuel system. B, the illustrated parts manual. I mean, if it's available, it does give you, it looks a little bit like a schematic, parts of it, or a fuel system schematic, which is the correct answer. That's why we talked about schematics going into the question. And it's a drawing or a diagram. It gives a lot of useful information. And if we had more time, we could look at a schematic even closer, which is something you could do in your shop time. Internal leaks, so they don't necessarily, you're not going to find any evidence of them on the outside of the aircraft. You're not going to find any leaks, but they're still leaking. It's internally. That's one of the most difficult problems to track down in a fuel system. It's often possible to isolate a portion of a large aircraft fuel system that has an internal leak by watching the fuel pressure gauge and operating the selector valves. All right, so that's basically how I was detecting leaks in the earlier answer. So I'd have to look at that a little bit to see if it was it was asking about visible external leaks, or either external or internal leaks. And it's often valves that are at fault if there's an internal leak. If the fuel pressure drops, or if the boost pumps must run continually to maintain the pressure, the selected portion of the system may have an internal leak. So you build up the pressure in the system with the boost pump, and you turn the boost pump off and see if the pressure starts to drop or not. If it does drop, maybe you can isolate certain sections with the fuel selector valves to at least narrow down where the internal leak may be. But like they say, it's the most difficult problem to track down. Question. The location of leaks and defects within the internal portions of the fuel system can usually be determined by, well, my answer again is C, observing the pressure gauge and operating the selector valves. One of the reading questions are very close to that. The other options, a visual inspection for wet spots, well, it's an internal leak. So you're not going to see it outside of the outside of the inside components. Or B, performing a fuel flow check. Not exactly sure why that's going to tell you if there's a leak or not. But it is C. That's how you determine internal leaks. Maybe a decent part of the answer to that previous oral question that we saw. But keep that in mind. So you're looking at the fuel pressure gauge and operating the selector valves. When inspecting any fuel system for leaks, turn on the boost pumps and visually inspect all valves located downstream of the pump for an indication of leaks. Okay, so you're going to look at every valve and check for leakage, and a lot of times, you're going to be feeling for moisture. And if the boost pump's on, the pressure is built up in the system. So if there's going to be a leak around a valve, that's when it's going to happen. When inspecting a fuel system, you should check all valves located downstream of boost pumps with the pumps A, at idle, B, dormant, C, operating, or D, turned off. Operating. Keep those boost pumps operating if you're inspecting the valves downstream of boost pumps. And producing maximum pressure. The drain plugs or valves in the fuel system should be opened and checked for sediment or water. The filter and sump should also be checked for sediment, water, or slime. The filters or screens, including those provided for flow meters and auxiliary pumps, must be clean and free of corrosion. Now, it's a fairly simple act to sump the fuel tank, and it is often used in oral and practical exams as a measure of your competence. So I would practice once or twice, normally on the bottom of a strainer in front of one of the trainers that we have. Fuel valves can be checked for internal leakage by draining the strainer bowls, placing the valves in the off position, and turning on the fuel pump. If the valve leaks, fuel flows into the strainer bowl. Okay, well, that's interesting. That's one of the maintenance little inside information. Tricks of the trade, if you will have. So basically, fuel valves can be checked for internal leakage by draining the strainer bowls, placing the valves in the off position, and turning on the boost pump. All right, so you're trying to block the fuel with the valve because the valve is off, so it shouldn't let any fuel past it. It'd be like a shut-off valve or a check valve. If the valve leaks, fuel does flow into the strainer bowl. All right, that's pretty clever. And there's a long-winded question that is basically asking for that procedure. What method would be used to check for internal leakage of a fuel valve without removing the valve from the aircraft? How can you check that valve while it is still installed? Just like we said, um, put the valve in the off position, drain the strainer bowl, and with the boost pump on, watch to see if fuel flows to the strainer bowl. I'd say that sounds good right there. Let's make sure B and C don't apply. Remove the fuel caps, turn the boost pumps on, and watch for bubbling in the tanks. No. Or C, apply regulated air pressure on the downstream side of the fuel pump and listen for air passing through the valve. No, watching for bubbling and listening for hissing. No, that's not the proper way. It'd be A. Have the valve off, turn on the pump, and see if you're getting additional fuel into the strainer. Is it possible for a fuel system to develop a leak that has no visible evidence, such as a stain or spot, and if so, how? Well, they're almost cluing you in that it is possible because you have to answer the second part. So just saying no, it's not possible, they're going to shut you down if you use the word no. So yes, it is possible. It could be an internal leak. And that may be enough to keep the examiner satisfied. Yes, an internal component such as a valve could develop a leak. All right, using the example of a valve certainly doesn't hurt your answer. Another miscellaneous topic is if you're going to be running fuel lines. We covered this in other classes, but where should you actually put the supports? And it kind of depends on the OD of the tubing. And normally you're going to be dealing, I believe, with 3/8. And so I'm looking for 16 inches between the different brackets. And usually a cushion clamp. Although you can see if it's a very thin tubing, your supports are going to have to be a lot closer to each other. And if it's very thick, they can be pretty far away from each other. Let's see. All fittings heavy enough to cause the line to sag should be supported by means of other than the tubing. Place support clamps or brackets for metallic lines as recommended in this figure. All right, when installing a rigid fuel line, 1/2 inch in diameter, at what interval should the line be supported? A little unfair, even though this table appears in the AC, it does not appear in the test. You're mostly going to be dealing with 3/8 to 1/2 inch. Yes, so that's that. Oh, I already have the table here, sorry. And that's going to be the 16-inch answer. Just look at the table and carry it across. It is in the AC. And for fuel lines, that's mostly what you're going to be dealing with, 3/8 to 1/2 inch. It depends on the aircraft, of course. You could be in a super carrier. Gaskets, seals, and packings. This will be a big part of your job when you're working on fuel components. The leak can also often be repaired by replacing a gasket or a seal, and you may have already discovered that just with your lawn equipment or even your automobiles. Sometimes if there's a leak, you just change the seal or the gasket and you're good to go. Or applying sealant also, or both. So let's see, if you're going to replace a component, or if you do have a leak, or if you're going to reassemble it after doing some maintenance, you took a fuel pump apart, a new gasket seal or packing must be installed. And for practice in the shop, we don't have an unlimited supplies of these, so we may not be actually tearing it apart, putting it back together with new seals. But that's mostly because we're not dealing with airworthy vehicles, and we're just learning the procedures. But if you're in the field and you are tearing down a fuel component, when you put it back together, you do use new appropriate seals and gaskets. Do not use the old ones. Make sure you're using the correct part number, and if you do it a number of times, you'll get to know those MS part numbers pretty much like shorthand. Also, most gasket seals and packings have a limited shelf life, and they're usually marked right on the package they come in. They're not going to be marked on the seal themselves, but on the package. So when you go to take it off the shelf, make sure you check to make sure the expiration date is not expired. What procedures should be followed regarding gaskets and seals when replacing fuel system components? Replace the old gaskets and seals with new ones, and make sure that the new ones have not exceeded their expiration date, and that they are the correct part number for the job. And I think they might actually even mention you don't necessarily rely on what you took off, because somebody may have put in the wrong seal. You don't have to go into that much detail. All old gaskets and seals should be replaced with new ones. All right, I should have stopped after the first 10 words. They would stop you. They're not going to let you. If you're being asked, let's say you're doing airframe in general at the same time, the oral and practical, if you're getting 4 per subject, you're in, 10 in general, 9 or 10, depending on how you classify ice, rain, and fire, are a total of 20 times 4. That's 80 questions you're going to be asked. So you're not going to be allowed to ramble on for too long, especially if you've already started with the right answer. Go ahead and take a look at the review video. If it's available, I'm still bound and determined to include those. A couple supplemental questions. Here, instead of calling it a stain, they call it a slow seep. I might have said a light seep. So a slow seep, up to 3/4 inch. And then seep and heavy seep are pretty much the same that we already looked at. If the surface area of a collected fuel from a leak is 3/4 to 1 1/2 inches in diameter, what is that leak classified as? Well, up to 3/4, it was the stain, or what we saw in there, the light seep. I forget the word already. It wasn't that anyway. 3/4 to 1 1/2, that's going up the ladder, so that was a seep. That's what this question is asking. 1 1/2 to 4 was the heavy seep. And then running leak is above that. So the correct answer here would be seep. Let me go back to see what that word was. Slow seep. It's the only place I've seen it referred to. Even the question doesn't have that as an option. It's using the stain. So I would go ahead and use stain as the correct nomenclature. If you're going to route the fluid line near the wires, do we have this correct? The wires are above the fuel. So if there's a leak, it's not going to fall on the wires. Or if there's a electrical fire, it's going to be above the fuel line. Um, when wiring must be routed parallel, well, it's not parallel here, it's perpendicular. Um, as much separation as possible should be maintained. The wires should be on a level with or above the plumbing line. No wire should be routed so that it is located nearer than a half inch to a plumbing line, nor should a wire or wire bundle be supported from the plumbing line that carries flammable liquids or oxygen. Which this would be more of a separation bracket. It's not actually supporting either. It's just keeping the two of them apart from each other more than a half inch. If a fuel line and an electrical wire bundle are parallel to each other, the A, fuel line and the wire bundle should be on the same level. No. B, fuel line should be above the wire bundle, or the fuel line should be below the wire bundle. Take a second to think about it, but the fuel, think of it dripping, and you don't want it to drip on the wires, so the fuel line should be below the wire bundle. What type of fire extinguisher do we use? Well, Class B. Class A is combustible materials. B is liquids. Oops, they have B here twice. C is electrical. Do I get that right? Liquids, then electrical. C is electrical, and then D is metal, like the tires or brakes. Yeah. All right. So, what type of extinguishers do we need for fuel systems? It already tells us Class B, so it's going to be this category: foam, loaded steam, multi-purpose dry chemical, carbon dioxide, dry chemical, halon 1301, halon 1211. The most common is going to be carbon dioxide and probably dry chemical, or multi-purpose dry chemical, I would say. So in this range. Fueling personnel must know exactly where they are and how to use them. The question might come up. The type fire extinguisher that is not recommended for a gasoline fire is A, carbon dioxide extinguisher, B, soda acid extinguisher, or C, dry powder extinguisher. Well, we saw carbon dioxide and dry powder on the acceptable list, so I didn't see a soda acid. I mean, acid, but the word acid itself doesn't sound like a good way to try to extinguish a gasoline fire. So B is the one that is not recommended. All right, and then I've redone the questions from a different publisher. If you, I'll include those in the PDF version of the presentation, so you can review them and maybe get a different explanation. But other than that, we're going to go ahead and wrap it up, and thank you for joining me for aircraft fuel systems. All right, good luck on finishing this class up. We'll see you later. Bye.